That was the big thing. Yeah, when we got started, most of the print farms that were around, you have people running up and down rows plucking parts off of the machines. And that's just not feasible if you're trying to hit real scale. The machines need to be self-tending. And then people can maybe come by and grab bins of parts. Then it works. But so yeah, the automation was the very first thing that we really started tackling.
Hello there, Internet, and welcome to the 3D Print Authority podcast. This is a place where we come together to have a transparent and no BS conversation about the world of 3D printing and technology. My name is Adam Fosnot. I'm a mechanical engineer, and I have been fascinated by 3D printing for as long as I can remember. Let's get started. To kick things off, Gabe, thank you for joining me. I would love it if you could introduce yourself to the audience.
Sure. Thanks for having me on there, Adam. So I'm Gabes. I run Slant3D. We focus exclusively on high volume FDM production of 3D printed parts. So we deploy 3D printing farms with several hundred machines in order to produce tens of thousands of parts per week as a pure alternative to injection molding. But in addition to that, a recent thing that we started releasing was angled.io, which is now the print on demand component of the business, which just allows people to basically replace the entire supply chain. We're replacing Amazon warehouses, ships, boats in China completely with just a warehouse where the shelves themselves make the stuff that's on the shelves. So that's kind of what we're messing with anymore.
Yeah, that sounds really cool. I was just on your website a little bit and I picked up on angled, which I'm now piecing together. It's like slant and angled. They're very similar words. I'm sure that was intentional. But so I'm excited to dig into all those areas. Before we get there, I thought it'd be cool to help the audience get to know you a little bit better. Could you share something about yourself kind of outside of what you do for work?
I like to read and I play a little bit of improv piano.
Improv piano. I like it. I like it. So much respect for that because I have zero musical talents whatsoever.
Okay. Not very useful very often.
What genre do you typically find yourself reading?
A lot of nonfiction.
Okay.
I really like history, like pre-World War II and that kind of thing.
Okay. Gotcha. Awesome. Again, nothing but respect. Sometimes I wish I could read more. It's something that I struggle to do. I know it's good for me, but sometimes the motivation just isn't there. So production FDM 3D printing is such a cool concept. And I think it has a lot of potential. So I guess how, when, where did Slant3D get started? Where did you kind of start this vision for production level FDM?
So Slant3D was started as part of a previous company called Slant Concepts.
Okay.
Slant Concepts was a product design firm. And what we had created a series of STEM robotics kits for kids to build about 4 years ago or so. Okay. And we thought we were going to sell 100 of these things, move on with our life, move on to the next project. But they ended up being a much more successful product line than we had anticipated originally. So we ended up building a small print farm for production of that. And by operating that thing, we realized, oh, there's some really nifty things that we can do as a robotics focused product firm to really make this an automated process to where 3D printing can really scale, not to 1,000 parts or 10,000 parts, but to millions of parts. So we started building that. And of course, as we started growing, we started bringing in external clients who also needed production. And then we just decided to spin it off completely as its own company about 2 years ago.
Okay.
So that's how it came about. We had a product that we were making, and then we just decided that the service was a more valuable thing.
Gotcha. Interesting. And so it's kind of cool to see how you identified the problem by, I'm guessing, experiencing it yourself in terms of part volumes and the feasibility of that. From an automation aspect, I think that's one of the biggest challenges for FDM and 3D printing as a whole. How are you able to achieve that?
So we had to start completely from scratch. We stripped printers down to the bare essentials of what you needed for a 3D printer, and then made a production machine. Because up until that point, desktop machines were always, or will continue to be, consumer devices. And a consumer device is absolutely terrible for any type of industrial application, because they have too many bells and whistles to make it easy to use. And they don't have the lifespan that we need. Our machines operate 3 years, 24/7 without stopping or taking a break. And there was nothing around that could do that. So we completely redesigned the printer and optimized it so that it was a good production machine. And then we were pretty good at software and that kind of thing. So we were able to give them the intelligence they needed to both eject parts and keep track of failures, so that you only have one person about every 150 machines right now in most of our facilities for maintenance and that kind of thing.
Okay.
And then a lot of material science around just adhesion and that kind of thing that we continue to develop all the time.
Okay, interesting. So when your printer is done building a part, what happens?
It removes it and it starts another one, and it goes until it's done.
Gotcha. That's so different than every other 3D printer.
That was the big thing. Yeah, when we got started, most of the print farms that were around, you had people running up and down rows plucking parts off of the machines. And that's just not feasible if you're trying to hit real scale. The machines need to be self-tending. And then people can maybe come by and grab bins of parts. Then it works. But so yeah, the automation was the very first thing that we really started tackling.
Gotcha. And then every now and then I lose my train of thought. And this is one of those situations. So you're building your own machines, and you built them for the print farms specifically. So do you only offer a service? Do you also sell the machines like as one-offs to consumers? Where is your focus?
The focus is entirely on the service, the production capacity, because we're moving in a direction where we want to be a manufacturing backend, where we're just like the servers of YouTube. Nobody cares. Anybody who's making a video or watching a video does not care about how the video is transferred from one person to another. We're doing the exact same thing with widgets. And that's the goal, to make 3D printing farms the manufacturing server farms.
Gotcha.
An industry 4.0. But with our machines, yeah, we designed them internally and we continue to manufacture them internally. About a year ago, we did release a consumer version of our production machines. It's called the Mason. And the reason we did that is because with a lot of our production customers, they are prototyping. But since they would always prototype with whatever kind of machine they had around, there was this translation between the specs of our machines and the specs of their machines, or whatever software they were using, whatever we were using. So there was this sampling, verification, back and forth, tweaks, and all this stuff that would go on for potentially weeks just by mailing stuff back and forth in the mail.
Gotcha.
So we decided, here, take one of our machines, get it the way you like it, and then just email us, and you'll know that once you have a prototype that you like on the Mason in your shop, you can email us that file and we can make 100,000 more exactly the same. And there's none of this translation going on. So it just streamlines the client process there. So that's the reason we built the Mason.
Okay. When you're taking customer orders, is there like a volume that people are typically looking at?
Oh, I don't know if there's anything typical there. It ranges from 100 to 1 million, depending on who the client is that we're working with. I mean, there's the brand new inventors who are creating their first run and kind of testing the market, finding out if it'll work. And then the established corporations or growing businesses that just want to scale up. What people are starting to realize more and more is that 3D printing and injection molding should not be compared right there at the manufacturing point. The cost per part of a 3D print might be slightly more than a mold most of the time, very rarely. But once you have the mold, you're required to then move the inventory around, and the inventory management costs add on 25 to 30% to the cost of a product just in general. Shipping it across the ocean, storing it in a warehouse for 2 years, so on and so forth, as compared to a 3D print where you have very limited capital tied up. You get parts as you need them, and they're never stored because they go directly to the consumer. So the value of 3D printing is becoming more recognized in the other parts of the supply chain outside of just making the part. So our clients are able to move into larger and larger volumes when they realize, oh, we just eliminated the warehouse and the shipping and all this other stuff that saved us a ton of money. Generally, though, 3D printing isn't even more expensive than injection molding. We have a cost parity with molding of about 100,000 parts.
Okay.
So it doesn't even matter anymore because you can make a whole bunch of cars with 100,000 parts. For Toyota, their maximum for production is 25,000 pieces.
Okay.
So to get up to 100,000 is just fine.
Gotcha. So the 20 to 30% is a number that I hadn't heard before in a lot of my reading and research.
But yeah.
Hey there, real quick. If you are enjoying this episode, could you do me a favor and subscribe wherever you might be watching or listening? It's totally free. It helps you not miss new episodes when they come out every single week. It tells the internet algorithms to help our content reach more people, and it would really make my day. I hope you think about it. Thanks.
The amount of carrying cost is really often very difficult just to nail down because it's so many different chunks of it. But yes, it's a minimum of at least 25%. The lowest we've seen is maybe 15, but very often even more. If you're ordering pieces from China, depending on how many containers you get, the shipping could equate to the same cost as the cost of production, especially right now.
Yeah.
So yeah.
Yeah, I've sourced plenty of parts from China, and looked at the shipping versus production costs. The shipping cost is definitely a kicker every time. But again, I had never heard it said, I guess, quite so clearly. So thank you for that. When you look at, just reiterating for my own understanding. So when you take into account the shipping, the warehousing, the time it takes to sell out of a large amount of inventory, all of those will add up to at least 20 to 30%, depending on the product.
Yeah. Inventory management is a bigger chunk of manufacturing costs than many people realize.
Do your clients come to you already understanding that, or is that something that you have to kind of work with them through?
It's getting better understood throughout the industries, because they see it down the line. They're like, oh, well, we paid a little bit more for the machines, but now we're saving all this other money all of a sudden. There's some kind of downstream benefit. So that is becoming more into the general knowledge of the industries that we work with. But very often now we got to remind people and bring it up. And it's so contextual depending on what you're trying to do. That it's a tough thing to point to specifically for any individual product, because there's a lot of ways to rejigger that cost as opposed to comparing it directly, a 3D printing quote directly with an injection molding quote. That's really easy.
Yeah.
So it's tougher to say there's all these other downstream benefits after you get the first part.
Right. What clients or industries do you serve with this level of on-demand manufacturing?
So a lot of it is industrial components. So wheels, gears, brackets, hardware, that kind of thing. Those are kind of the easy ones because there's not really any sort of stigma attached to FDM 3D printing. And it creates good quality engineering parts that can be made from any type of material. That's a standard thermoplastic. So they're easy to replace and integrate because people understand what's being made. On the consumer side, we cover the full gamut of stuff from, yes, cases to headphone stands, to toys, to widgets, to whatever it happens to be. That the consumer side is exceptionally broad. So, but consumer products are very common, especially if the designer who is making the product is able to optimize for the process. There's still a large education gap in product design using additive manufacturing. And I don't just mean for like layers or picking the right stuff or orienting your part, but in the way to design a piece that takes advantage of the process fully. Like FDM can make a part as good as injection molding. The problem is the part won't look the same as the injection molded part. And this is what people don't get, because they keep on taking an injection molded design, having it 3D printed, and then are disappointed by the results, even though the rules are completely different. It's like trying to make an aluminum airplane out of wood. It doesn't work very well just because you're not using the strengths of them all. So that's a challenge in the industry that is coming along and becoming easier, but still exists, because there's this, you're trying to put a square peg in a round hole. Both holes work fine. You just have to make sure you're preparing for it.
Yeah, this is something that I've spent a lot of time thinking about, is exactly what you're hitting on. Is if you take a part that was designed for injection molding, you're gonna have thin, evenly sized, even thickness walls all over the part. You're going to be expecting a nice, beautiful, smooth surface finish. You might need painting afterwards. You might need texturizing afterwards. You might need all these different things to get to the end use part. And FDM is just different, right? You wouldn't choose to make a cylindrical part on a vertical mill. That would make any sense. A lathe is just a much better tool for what you're using, and both processes have different rules and parameters. Is that something that you find yourself working with clients a lot to optimize their design? Do you kind of put that ball in their court? And how do those conversations come about?
Well, it depends on the client, because changing the design. Very often, the only thing we ever have to tell them is like, okay, you've got your part right now. Here's the fundamental rule for FDM parts: fatter, thicker, rounder.
Okay.
Get as close to fill it all. Don't worry about volume. Try to minimize surface area, because surface area is number one where all the strength is, and where all the material is. Mm-hmm. So you take like a simple bracket that's like this or something that would normally be injection molded, so it's like a square channel or something like that. You have the mold, cut out a big old chunk of that channel. But with printing, you can make that a solid square brick, and then you don't have the channel anymore, but you have as much, if not more, strength. But so we generally say that's the best way to go about it. If you want us to have our engineers go through and tweak the design, we can. It just depends on the timeline and that kind of thing there too.
Sure.
So yeah, that's the restriction there.
You seem really knowledgeable about 3D printing. When did you first kind of get exposed to it and start getting interested in it?
I hated 3D printing forever.
No. Please explain.
When we started the print farm back at the previous company and started making the 3D printed bots, I had absolutely zero intention of being involved with it at all, because I was ticked at what was kind of available and how it worked in general. And I'm a very engineering purist, where I was always angry when a colleague or a friend or someone else would go and 3D print a plate with a hole in it, when you should have just gone and gotten a chunk of wood and drilled a hole in it. That always made me, I was never a fan of 3D printing, especially consumer printing and stuff, because I never once believed that there would be a printer in every home, because that's like having a bandsaw in your kitchen. Anyway.
That so was a wonderful take. I've never heard it said quite so clearly before.
Yeah, I've had to defend this for a while now.
Oh, I'm sure. I can see the hordes of people waiting to come after you right now. Continue, please.
But yeah, when we started the project, once we saw that fundamentally 3D printing should be equivalent, if not better, than injection molding, because they have the same inputs. You put in plastic, you put in electricity, melt the plastic, and you get a part out. 3D printing should technically be much cheaper than molding, because you eliminate the mold and the inventory and everything else. So on a very fundamental first principles kind of a way, printing is a better process. Then you get up into the technology and you're like, layer lines and isotropy and all the rest of it. But those are all engineering problems that are really easy to address. Once we saw that, it became really interesting and cool, because there was this very clear path of how to make printing scalable and make really good components. And that was exciting to me, because then it was an obvious solution to this very long and existing problem, both with the 3D printing industry itself and general manufacturing. So I got on board once we started messing with the first designs of our own machines or so. That's when I really got behind it. And it became exciting then because it was a step difference in how to make stuff. And there was a clear road of actually how to achieve that ideal.
Gotcha. Okay. And so in the very early stages, what was the team like? How many people were you working with? How much time was focused on developing the printer versus, I guess, supporting your STEM robotics product?
Well, you always have to prioritize between theirs, and things always move up and down. The team, when it started out, was only about 2 or 3 people there.
Okay.
Because we were a product consultancy, and a lot of us just did what we did. So we went through it, and we worked very iteratively, because we're not ones where we're like, we're going to come out and in a year we're going to work really hard for a year, and we're going to come out and have an anti-gravity machine at the end of it all that's going to stun the world. We're a very just each day grab 1%, make a tweak, tighten a screw, replace a part, eliminate a part. And as you're running through it and as you build more machines, you're able to make those very iterative changes as you build each new version of the machine. So it happened organically, and no one would ever point to right there was the flip, and that was the big change, and that was the big shift. It's just the only way you would get that idea is if you took a picture at 1 year and then at 2 years and so on and so forth, and then you start to see the gigantic changes that happened evolutionarily through there. But yeah, it's an ongoing and continues to be an ongoing process.
Gotcha. And today, I think before I hit record, you said that you were looking at or just starting a second facility. So at your main facility in Boise, how many printers and people work there?
Here in Boise, we have our main sales and marketing office and everything else. So there's all those folks. The printers themselves, it's spec'd out for 800 machines here. And we're almost done.
Okay.
But that facility, we'll have all those built out here. And then Austin, where we're looking to move to our second facility, is going to be similarly sized. And we'll have a much heavier focus kind of towards software and that kind of thing too, and new product development. But yeah, it's overall the company is just a few folks still.
Okay. Gotcha.
But yeah, it's about 1 person per 100 machines for technicians and that kind of thing.
Sure. When it comes to building these printers in-house, are you laser cutting your own sheet metal, machining your own aluminum profiles? Like, how much of it is in-house versus sourced collectively and then assembled in-house?
Do you have a question about 3D printing? If so, I would love to answer it. Feel free to leave any questions in the comments down below, or go to 3dprintauthority.com/forums to submit your question. Thanks.
Well, we have the benefit of being in a very manufacturing-oriented community. So there's a lot of machine shops around that we get to source from. And I love having those partnerships, because ideally any supplier you have is better at making the part than you would be if you brought it in-house. So the only time we ever bring a component in-house is if we just can't rely on anybody to produce it well. But right now, almost, I think 90% of the parts on the machine are custom designed by us, and the remaining are off-the-shelf kind of components. And almost all of them are manufactured here in the Boise area.
Gotcha. That's really cool that you're able to source so locally. And I can relate to what you said about, like, if I'm bringing it in-house, I'm going to make it worse than the shop down the street.
Right.
If there's a sheet metal shop that's been in business for 60 years, like, they know what they're doing way better than I do.
You would think.
Just let them do it. and
Exactly right.
And you get to support local businesses and, all that good stuff.
There's all that good stuff, but it really should just be a matter of some other company that has existed and survived should be really good at what they do. And it's frustrating when you run into the companies that just aren't, because they don't care, they're indifferent about it, or whatever reason there.
Yeah.
But it just makes no sense. I don't want to vertically integrate particularly. We're a 3D printing company. We 3D print stuff. But to then have to manufacture filament and manufacture our machines and all these other things simply because there isn't an option, even from the people doing it, we do it because we have to, not necessarily because we were wanting to.
Gotcha. So do you manufacture your own filament, or is that sourced from reliable suppliers?
Yes.
A little of both. A little of both. Okay.
We manufacture a lot of our filament in-house for like standard commodity materials like GLA, PETG, that kind of stuff. A lot of that is made in-house and continues to expand. The reason for that is really, again, the 3D printing industry being so consumer focused. There's very few standards that have to be in place in order to make the consumer happy, particularly around color. A filament supplier does not have to make the exact same perfect Pantone color of red from one month to the next. They can eyeball it. And since the only person checking them is a guy in his garage eyeballing one spool to the next, no one ever knows that it's not the same red. We kind of notice when we make 100,000 parts and then a month later try to make the same 100,000 parts and it's the wrong color. Off just by a shade, and nobody can tell by eye, but we know because we're continuing on from something. So that was the big impetus for us to bring it in-house, just so that we knew we could get the same dang color from one time period to the next. We also operate on really long time horizons. Many of our corporate clients have projects that are going to go over years. So we're going to make 100,000 for them this year, and then for the next 5. We need to know that 5 years from now, they will have the exact same part. And since the industry has so much churn in it, we just can't rely on that. So we had to have some foundation that we controlled to make sure that we were producing a good quality part for our clients.
Right. Color is one of the biggest things that I would point out. I used to work at an industrial printer distributor, and people would be like, filament on Amazon is $20. Why is your filament more expensive? And I'm like, but when you buy a roll on Amazon and buy what you think is the exact same one 6 months later, it's not the same. And you got to be doing it for a while and like have not used the previous roll to sometimes ever notice.
Exactly.
So I'm happy I'm not the only one to have experienced that.
Oh no, not at
all. How do your clients find you?
Every way.
Okay.
We're very active on most channels. We've got a sales team. It's just everything, a little bit of everything in that. We've also just been doing it longer than most. I mean, there's not a ton of print farms that have been around for any amount of time longer than like 2 years or so. So we've got the advantage of being the old geezer in the room at like 3 or 4 years.
Gotcha.
Yeah, it's just everything.
Okay. It was one thing I was just super curious about, because I'm like, well, there are other 3D printing services. A lot of people offer a broad range of technologies. And here you are, a print farm in Idaho, and how people find you just seemed, I don't know, it's a point of interest for me.
Well, I would say that focus is a big part of it, because if you look at many of the manufacturing or even 3D printing services, like you said, they have a lot of technologies. Therefore, it's really difficult to say what they do. Are they a prototyping house? Are they making engineering replacement parts or spare parts or anything like that? We do production as an alternative to injection molding. That's the fundamental thing that we do. So that's a fairly easy sell, because if you're ticked off at molding, or you don't want to buy a million parts or buy the mold, it's a really good value add to that pain point for folks, as opposed to being another prototyping shop or another machining shop that happens to have a 3D printer. It's also much less competitive because there's not many print farms out there, and really none that can hit the same scale that we do, that I'm aware of. Who knows what's cooking in China or Russia, or who knows what all, but it's publicly around and being used by normal folks. There's just not many of us there. So we've been over in this niche of production before it was really popular to be in production, which is a big value.
Yeah, I can see the value of focus there, because a lot of the bigger printing services will do everything, even so far as like, oh, well, we also do sheet metal and CNC and DMLS, and we'll do 1 part or 10,000 parts, but you have a very clear, this is who we are, which I'm sure helps people be drawn to you. Do you find yourself using some materials more than others when working for clients?
Oh, no. It's all over the board and dependent on the client there. Yeah, we don't have a real favorite.
Okay, gotcha. That's a wonderful, simple answer. And it's funny, in my past experiences talking to lots of other manufacturing job shop type companies, they usually have very similar answers where, oh, do you use one material or another? It's always all over the board, it's just depending on what they need.
Yeah, you create what the client needs.
Yes. Another thing that I've been curious about is print management. So do you have systems in place to do that? Are all your printers internet connected? Do you just run over there with an SD card? Can you share some insight to that?
We used to run around with an SD card. Quite bluntly, because the SD card is actually phenomenally efficient in many ways, especially in production, because you're setting the machines and leaving them, and then their onboard intelligence can just take care of them there. So having the connectivity exposes you to risk and loss of connectivity that can kill everything. So we used to do that, and there was nothing wrong with it. But no, yeah, anymore, all the machines are networked, and we've got wonderful little bar graphs of everything. And our developers are building software in-house all the time that expands and builds it out more and more. Because again, there's just nothing really commercially available. It works very well for the specific thing that we're doing, and the sheer scale of what we're doing. So yeah, they're all networked, and we have a God's eye view of them all anymore.
Gotcha. That's awesome. And it's homegrown software.
Yeah.
Okay.
Yep.
I think, to your point, there isn't a lot out there that would solve your problem.
Hey there, it's Adam. If you're enjoying this video, could you go ahead and tap the like button? It's totally free for you, and through the magic of internet algorithms, it will help more people see the podcast. Thanks.
Not really. We tried them all. It was exactly like filament or everything else. It was all fine, and the ones that were almost there were just terrible.
Okay.
It's amazing how much 1% makes, or whatever it was. And my background in like product design, and I did a lot of web development and UI and industrial design and that kind of thing. So it really irritates me when somebody has an extra click in a site that doesn't need to exist. Okay. Especially. Okay. But yeah, so many of the cloud softwares that were for FDM consumer machines or fleets or print farms are used to 5 to 10 machines maybe, and generally just the guy who wants to view what he's printing on his phone. And that's not useful to us in any sort of way at all when you have thousands of parts being made every day, stored in inventory and digital and all the rest of it. It's a completely different monster than I'm going to print another benchy today. I need to make sure it's done.
Again, lost my train of thought, so I apologize.
No worries.
Because I can relate to, I think, both sides of a lot of what you're saying, where, as you know, some days I am just the guy that needs to make sure the benchy sticks in the first layer. And a lot of other times I'm the guy that's, sourcing parts and running through these headaches and like tracking inventories and all that.
Oh, absolutely. Many of the softwares are really good for the consumer. They just don't work well in production.
Yeah.
And you know this, if you walk into a factory, it's all very bare bones, and the UIs are very to the point and get on with their lives. And there's not the logo in the corner and the wonderful spinning circle or these other kind of things that are artistically there and help the user interface. They're efficient. They're not necessarily always comfortable, though you should always push towards that when you're building a system. But there's there's bells and whistles that occur in consumer products that you just don't need when you're making a system.
Right, right. That makes sense. Can we talk about some of the growth of the company and how that has happened over time? Has this all been kind of bootstrapped? Has there been VCs along the way? Because I think the vision that you guys are going after with production level 3D printing might be something that VCs are interested in.
Not many of them.
Okay. Okay.
Well, no. Manufacturing as a VC funded system is not generally very popular, because manufacturing with a traditional VC model where you're looking for 100 failures and then the 9th one is $1 billion company, manufacturing doesn't generally show a roadmap to that that's very popular, because it's way more effort to make a plastic part than it is to sign up another Facebook user. So the scalability is different. So a lot of VCs don't care for manufacturing companies. That being said, we are funding right now. We're in the middle of going through that process at the moment for the next stage of growth here, because we've cracked many of the nuts around that scalability to where we can tell an interesting story about the fact that, we're building servers here. And I can't go too much into that. Anyway, we're in that process right now. Up until this point, the company has been self-funded, mainly because so much of it was new and different that we just decided you don't go funding until you know what it is that you're doing and how you're going to do it. Then you're just another charlatan out there looking for money. So we were very strict about the fact that we had to know exactly what kind of business we were making. And the reason that was so difficult to do is because 3D printing can go any direction. Like you said, there's 20 different technologies and 10 different variations, and you can make one part or 1,000 parts. You can do it in resin or FDM. You can work with corporate clients or consumers or inventors. There's just, when you can make anything, you now have the opportunity to make anything, which is a terrible business model. So we had to navigate that and say, okay, this is the roadmap that we're going to have that has been proven to work based off the last little bit of time we've been working on it. And now we're at a point where we can say, okay, we have lit a match. Now we can dump gasoline on the fire. And that's what VC money is for.
Yeah. When we were talking earlier and you mentioned the servers aspect of it, like I work with 3D printers all the time. And so I understand 3D printing and printing at somewhat large volumes. But looking at it conceptually as the server nobody cares about, but that the so many end products couldn't exist without them sounds incredibly valuable. In the time you've been working on Slant3D, what would you say the biggest challenge you've experienced so far has been?
Oh, you get kicked in the teeth every other week or so.
Okay.
The nature of the beast.
What do you mean by kicked in the teeth?
Well, when starting any business, it's you have to have a high tolerance for pain just in general, because there's never a scenario where, by golly, you were so darn great that you're a billionaire overnight or whatever it was. There's these horrible moments that come up more often than you think. And most of the time when you're really trying to achieve something difficult, they come up a lot more often or just constant. Because in my position, everybody brings their worst problems to me.
Okay.
Because it's my job because nobody else is able to solve them. So I'm one of the older guys around who's hit a few of them, so that everybody brings those now to me until the experience is built up lower in the organization. So Elon Musk had a really good line about this. He said, starting a company's like eating glass while staring into the abyss, which is absolutely true. And the reason it is because when you start a company, if you're trying to grow and trying to achieve something every day, it's like putting more weight on a bar every day, therefore eating glass. but you still have to lift it. Otherwise, you go into the abyss. So I'm going to mix a number of metaphors there.
I like it. I like it. Keep going.
To push really hard, it means it gets harder every day because you're getting into thinner and thinner air and more things that other people have never done before. So there's no precedent, which means more things break and blow up and all the rest of it. The single biggest challenge for us, I don't know of one. It might just be because of the way we iterate on stuff. So technologically, the problems come in small bites, but just every day. I can't point to like a big old moment or time when it was like, yeah, this is the make or break. This is the big moment. I'm sure there's probably been a few, but they happen often.
Yeah, no, I think your take on that is very true from what I've experienced starting a company. And a lot of people, I think the longer you work on something, it gets more difficult to be like, oh, this was the biggest challenge. To put it, it ends up being lots of little challenges that you gotta take on every day.
Absolutely.
Now this might get a little more philosophical, but if you're trying to solve difficult problems every day, and I heard a little bit in your tone of voice that it can definitely be frustrating at times, whether they're people problems or technological problems. Why bother? What's I guess the driving force between wanting to achieve something that's really difficult for Slant3D?
Do you want to be a guest on this podcast? If so, go to 3dprintauthority.com/forms to apply. Thanks.
So things, if you see a thing that can be done, that could be done, or that should be done, whatever, and you go on with your life, there is no guarantee that that thing will get done. So I could say, yeah, I'm going to go sign up, go use my engineering degree, go work for Google, make a $1 million a year or whatever it was. And somebody will go build printer farms. Not necessarily, because the world doesn't move in that direction all the time. It'll move in any direction. You don't know if it'll be that direction. So it's basically a point of personal responsibility where if you want something, go ahead and go make it happen, because who else is going to? You don't know. Somebody might not. And as far as my incentives of it, I just want to, there's very little that you're going to have in this life that's going to stick with you once you die. So I want to make sure that when I die, I get to say, what did he do with his life? I get to say all that I could have.
Yeah.
And I take a very functionalist view of that. I'm not necessarily looking to climb Everest or any of the rest of it. I want to make sure that there's a remnant of something that pushed the world a little bit further ahead when I'm dead than there was when I wasn't there.
Gotcha. I appreciate you sharing that. I know, personally speaking, a lot of times I'm a lot more comfortable talking, how hot does the extruder need to be and troubleshooting things like that. But yeah, as people with businesses and technologies, I think getting at some of the root of why you're looking to make an impact is interesting. We're going to wrap up with a couple a little higher level questions. And one that I've been throwing in the mix a lot more lately is, what is one thing that you don't like about 3D printing? Maybe you think it's too slow. Maybe you think 3D printers should all be bigger or smaller, or you can get a little creative with it. What's one thing you don't like?
Oh, printers aren't too slow. There's a transistor is slow, but you put 1 billion of them together, you suddenly have a computer that seems fast. So printing isn't slow, but The fundamental thing that I always dislike, or feature that I've always disliked about printing, is I hate the Cartesian machines with moving beds, because
Okay.
it's fundamentally wrong. Because you
Okay.
have a part, you're growing a part, and then you're moving the foundation of your part underneath it. And that makes no sense to me at all, because you wouldn't build a building on top of a fault line, but you're going to build a machine that makes a tallish part, and you're going to have the base of it move back and forth. That's just silly to me.
You hate the bed slingers?
Yes, every one of them.
They're so popular.
And I know they are all the most popular machines out there right now. It's still dumb.
I love it. We're gonna put the Pruses and the Enders and the CR10s. The CR10s are kind of where I can share your hatred, definitely, because at the point where you're dealing with a 500 by 500 millimeter bed and it's just moving back and forth, it seems very silly. Mm-hmm. Maybe on a smaller machine, but that's where I draw the line.
No, not even.
No, not even the smaller machine.
I will say, huge kudos to the Prusa software guys for tweaking that thing so that it works as well as it does, 8 inches off the bed. But they wouldn't have to if it wasn't fundamentally flawed from the beginning.
Ooh, I like it. Yeah, I've heard a lot of very mechanically minded people share similar grievances over the years, but regardless, it's a very good answer that I think has merit to it. Another one is, outside of your products and what you're working on, what is one thing in the world of 3D printing that you're really excited about? So this could be a trend, a specific technology, or just something that you want to see more of.
Oh, a trend or technology just in general, or in the 3D printing industry?
In the 3D printing industry.
Okay.
So I've gotten everything from like printed organs to houses to generative design, all sorts of these little nuances that people are really excited about.
Yeah. Of the things up and coming, the printed houses are the most valuable right now as far as a new tech. And then if somebody can figure out how to post-process resin machine parts in a way that's really efficient, that'd be a big deal. Because that's all still a nightmare in all kinds of different ways. But I don't know. I'm not, obviously, yeah, we're doing what we're doing for a reason, because we have some sort of ideal that everybody else is wrong in some kind of a way. So there's that bias in it. You fundamentally have to believe that when you're working on this kind of stuff.
Yeah.
I don't know. I do believe that like the topology optimization and that kind of thing is very overrated right now.
Okay.
Because it's an optimization. It's like going from 99% to 100%. You're only getting a very small improvement over just making a solid block of stuff.
Mm-hmm.
And a solid block of stuff is pretty easy to make as compared to the complexity of, yes, the organic shape that looks cool, but really doesn't gain you that much more than what you had before. It's great in aerospace where you're fighting for that extra pound or ounce or gram or whatever it happens to be, but I just don't see the broad value of it, especially in consumer products. Right. But there's not really a key technology there outside of continued automation and improvement. There's a huge amount of improvement that can be done in software and the overall standardization of what is a good quality part. Because if you go from one company to another, we all have kind of different references and spec sheets and that kind of thing. And it also, if you're serviced, then it varies from client to client. So some sort of standardization where you know this is a good part or no. That would be cool if we ever got to that point, though that's generally going to probably be driven by whoever the winners are right now. Mm-hmm. And it's also almost unfair because in injection molding, you don't necessarily have, that's a perfect part. It has as much variability really as 3D printing very often. Just most people don't see it. But the complexity is always there still. So that's a really long-winded answer that was probably a non-answer.
There were probably 2 or 3 fragments of an answer there, but I enjoyed it. I think kind of your last point around standardization of quality is definitely an area where we can all improve as an industry. And I especially like your point to where it's probably going to be determined by the winners. So whatever company, I guess, wins out overall can kind of set those standards and then have everyone else measure up to it. Sure. Regardless, thank you so much for taking the time to join me and chat all things 3D printing. I'd invite you to share where people can connect with you, where they can learn more about what you're doing at Slant3D, and any specific calls to action that you'd like the audience to take. Now's your chance.
Fair enough. Well, thanks, Adam, for having me on. Really appreciate it. This was a lot of fun. Yeah, folks can get a hold of me generally on LinkedIn. I'm probably the most active there. And then if you want to talk to Slant3D about production instead of getting some molds, you can go over to the Slant3D site there. But if you're a designer or a product designer or a 3D modeler who has created an original product and you don't necessarily want to have it made or build your own print farm, I really highly recommend angled.io. This is the big project for us because this has taken manufacturing from some kind of volume constraint to being totally free. You upload your model, and now one person or 10 million people can order the physical print and have it delivered in a couple of days, which has never been possible before. So we're really excited about that and giving physical hardware designers the same kind of capacity that app developers have had for 10, 20 years now. So that's the good place to go if you're tweaking and creating new things.
Definitely. That's a really exciting idea. I hope people take the opportunity to join you on that platform. Thanks.
Thanks, Adam.
Thank you so much for listening to my chat with Gabe from Slant3D. I think what they are trying to accomplish with directly competing with injection molding and disrupting supply chains is just so cool, and I hope that you think so too. Feel free to check out slant3d.com to see all of the things that they offer, including angled.io if you are a product designer. If you want to learn more about me, please check out 3dprintauthority.com. You can find all of our episodes there as well. If you haven't already, please consider subscribing to 3D Print Authority so that you don't miss an episode when they come out every single week. Until next time, happy printing.